Inflammation is an acute adaptive response to injury. An initial inflammatory response that does not heal completely turns into a chronic, low-level inflammation, which is strongly associated with many chronic disease states. The molecular events of the healing process are under significant dietary control and are termed as the resolution response, which can be defined by specific blood markers. The purpose of this review is to describe the molecular components of the resolution response and how different dietary factors can either optimize or inhibit their action. Inflammation can best be explained using a double-edged sword program. Some inflammation is needed to address physical injury, but the damage caused by initial inflammation has to be reduced, resolved, and repaired to significantly delay the development of a chronic disease. This balancing act involves molecular factors such as NF-κB, eicosanoids, resolvins, and AMPK. The gene transcription factor, NF-κB, controls the generation of inflammatory cytokines and the levels of COX-2 enzyme that produce many of the pro-inflammatory eicosanoids. Eicosanoids enhance the intensity of inflammation, while resolvins are necessary to turn off inflammation. Resolvins are only activated by inflammation. They also enhance the body's ability to kill and clear microbial infections. AMPK, the body's primary sensor of both energy and glucose, induce tissue repair by activating various gene transcription factors. This, in turn, promotes the regeneration of damage caused by initial inflammation and inhibits the NF-κB. An appropriate zone of inflammation is maintained along with optimal healing from any injury until the molecular factors are balanced. A chronic disease is often the consequence of a long-term accumulated organ damage caused by a blocked resolution response. A blocked resolution response first leads to the buildup of unresolved chronic inflammation, which increases levels of pro-inflammatory mediators, such as cytokines and eicosanoids. Following continued low-level activation of NF-κB, these inflammatory mediators can disrupt hormonal signaling patterns, as well as reduce the efficiency of both the innate and adaptive immune system. This leads to the development of sentient cells and the acceleration of fibrosis. It is now being recognized that chronic disease associated with aging, for example, metabolic conditions such as obesity and diabetes, heart disease, cancer, autoimmune, ocular, neurodegenerative, etc., are strongly associated with increased levels of sentient cells in the affected organs. New insights into the molecular biology of resolution response have led to the development of a comprehensive nutritional program termed Pro-Resolution Nutrition. This nutritional program represents a comprehensive, personalized dietary pathway to achieve improved treatment of existing chronic conditions, as well as extending one's health span. For example, the reduction of diclosylated proteins by reducing the dietary intake of glucose reduces the potential activation of RAGE, receptor of advanced glycosylated end products. The overall diet, specifically a personalized, anti-inflammatory, calorie-restricted, protein-adequate, carbohydrate moderate, but rich in fermentable fiber, low-fat, especially low in saturated fats and omega-6 fats, diet, named the Zone Diet. It is considered the starting point for optimizing resolution response. The Zone Diet was designed to modulate excess eicosanoid formation caused by insulin resistance in order to reduce inflammation. For the pro-resolution nutrition to be successful, it requires the Zone Diet to be continually used to reduce inflammation. It also becomes important to provide adequate levels of omega-3 fatty acids to resolve inflammation, and adequate levels of polyphenols to repair the damage caused by inflammation.